Hello classmates, we studied related content of direct current earlier. Then let's learn the content of alternating current. In this lesson, we mainly study three elements of sinusoidal alternating current. First, let's take a look at sinusoidal alternating current, which is used in various applications, such as household appliances. The electricity used is sinusoidal alternating current, and it is closely related to our life. In addition to domestic use, alternating current is extensively used in industrial and agricultural production. The main difference between alternating current and direct current lies in the fact that the direction and magnitude of alternating current change periodically with time, while the direction of direct current remains constant over time, with the size possibly varying or staying constant. Constant direct current refers to a current that does not change in size or direction over time. On the other hand, the magnitude of pulsating direct current changes with time. What is sinusoidal alternating current? It refers to alternating current in which both the size and direction vary over time, according to the law of sine function. And it is commonly known as sinusoidal alternating current, as shown in Figure 3.1.1. The waveform of several common currents are presented in an AC circuit. A wire through which current flows is referred to as the phase line, commonly known as the file line, and represented by the letter L. On the other hand, a conductor through which no current passes is known as the zero line, represented by the letter N. We can use an electric pen to determine whether a conductor is a phase line or a zero line. When the stylus touches the metal core of the wire, if the nylon tube is on, this conductor is the phase line. Whether a conductor is a phase line or a zero line, the conductor is the zero line. Figure 3.1.2a shows a common power socket panel, which is connected to a sinusoidal alternating current. Figure 3.1.2b is designed to test whether the socket is live using the electric pen. The results of the test show that the power socket is live and meets the requirement of having the left conductor as the zero line and the right conductor as the phase line. Next, let's learn about the three elements of sine quantity. As shown in Figure 3.1.3, sinusoidal alternating current can be expressed as I equals Im sine of omega t plus phi I. In this formula, the letter I refers to the instantaneous value of sinusoidal alternating current. I sub m is the maximum current. Omega is the angular frequency of alternating current. Phi I is the initial phase angle of alternating current. In the current expression, relationship between current and time is determined by the maximum value, angular frequency, and initial phase. At the same time, these three quantities serve as the basis for comparison and distinction between sign quantities. Therefore, maxim, angular frequency, initial phase are three elements of sinusoidal alternating current. First of all, let's learn what is periodic frequency and angular frequency. Sinusoidal alternating current completes cyclic change once, and the time it required is called cycle, represented by T. The unit is seconds. It is obvious that the time interval between the two maximum values adjacent to the current or voltage of sinusoidal alternating current is the period of the sinusoidal alternating current. Its expression is as follows: T equals 2 pi divided by angular frequency. The reciprocal of the period is the frequency, represented by the symbol F. The expression of frequency is F equals 1 over T. Frequency F indicates the number of cyclic changes of sinusoidal alternating current in a unit time. That is the alternating rate of alternating current. The national standard unit of frequency is Hertz. China adopts 50 Hz as the standard frequency of electric power. The United States, Japan, and other countries adopt 60 Hz. The change speed of sign quantity, in addition to the period and frequency, it is also expressed by angular frequency. The unit is radian per second. The relationship between angular frequency, and period can be expressed as follows. The angular frequency is equal to 2 pi divided by the period. It is also equal to 2 pi times the frequency. Next, we will learn what is amplitude or effective value. The value of sign at any moment is called instantaneous value, represented in lowercase letters. For example, I is used to represent instantaneous current. The largest of the instantaneous value is called amplitude or maxim, represented by an uppercase letter with subscript m. For example, the maximum value of current is expressed by Im. In sinusoidal alternating current, we often described the magnitude of each quantity by effective values. The effective value is determined by the summer effect of the current. If a sinusoidal alternating current I and a constant current I pass through the same resistance and a constant current I, then the generated heat will be equal. This means that the thermal effect of this DC current is equivalent to IS equivalent, that of the sinusoidal alternating current. Hence, the value of this DC current is defined as the effective value of the alternating current, which is denoted by uppercase letters, such as U for the effective value of voltage. Based on the above, using mathematical knowledge to calculate, we can determine the relationship between effective value and the maximum value. As shown in Formula 315, generally speaking, sinusoidal current or the magnitude of the voltage are valid values. Voltage and current measured by instruments are also the effective value of alternating current. Finally, let's learn the initial phase. In the sine current expression and waveform diagram, we can see that omega t plus phi I represents the phase angle of sinusoidal alternating current. Short for phase, it reflects the process of change. Sinusoidal alternating current. When t equals 0, phase angle phi I is called the initial phase. Initial phase phi ID value determines the angle of the timing moment. Different initial phases refer to the different starting points of sine quantities. When phi I equals 0, the initial value is 0. It is specified that the absolute value of the initial phase should not exceed pi. This is because there is a defined proportional coefficient between the effective value of sinusoidal alternating current and its maximum value. Therefore, the effective value, frequency, and initial phase can be combined and referred to as the three elements of sinusoidal alternating current. In order to deepen the students' understanding of knowledge points, let's look at an example. In this lesson, we learned about the difference between sinusoidal alternating current and direct current, as well as the three elements of alternating current. These three elements of alternating current are the focus of this lesson. Classmates, I'll see you next class.